works with an event loop in the parent script and concurrent for child execution. It's pretty cool. Not child execution, but the concurrency is pretty cool. Okay, that was a terrible joke. Easy concurrency is the last problem I wanted to solve. This code, the other two libraries, there are stable releases and you can experiment with it so far. This code is on GitHub, and I'll show you a link to where that is just now. But it's still unstable. I'm still working on the API. It's looking really good though. Let me show you what this does. It builds on the work of Remit, the event emitter, and Doorman, the multi-process manager, to have syntax that looks like this. We create a new thing called a proxy, which is driver-based, and in this case, it's a Doorman proxy. We have to create a process manager for it and a 0NQ server, and then we can add any number of event listeners to this proxy directly. So you can listen for events like new user registered, account cancelled, archive requested in your application, and then start doing those things in a separate process. Or you can use feedback from client scripts to say, this task had an error and this was the reason, do something on the server. You can add events directly to this, add event listeners directly to this proxy. Then you can write code like this. So proxy synchronous takes one function or an array of functions or an array of things that implement the task interface and does them synchronously. It does them in order, because if it's synchronous, it doesn't matter what order this thing is supposed to be executed in. But after that's executed, we can go on to doing parallel tasks. We can have an array or a single function or an implementer of the task interface. And all of these things are run at the same time in an unpredictable order. When they're finished, the next thing on the chain happens. So you can group different sets of parallel tasks to be executed, or you can do things like synchronous, a bunch of parallel tasks, and then a synchronous task at the end. And this synchronous task at the end depends on those having been executed. So if we run this, first sync task and yes. That's because this is emitted. That's because these are created, which means this results in true, and what is emitted is yes. And then we have some parallel tasks down here just to unlink those things. This is a combination of all of the concepts, well, not all of them, but many of the concepts I've shown you so far, using exec default processes, using a message queue to store state. It's a combination of all of that stuff in a very nice API, in a very practical way that you could use this. This is a very practical API for the web. And all that is to say, you can make your own tooling for this, or you can use libraries and frameworks that are already out there to do asynchronous code. It's not that difficult. You can find the code that I showed you, github.com/async PHP. Honorable mention to Icicle. This is another Icicle library called Concurrent. And it's I guess a more enterprisey version of the code I've shown you, where you can fork processes and have that stuff done in a separate process and have that data yielded back to your parent process. Again, it's code that looks like synchronous, it's actually asynchronous, uses generators, and it's awesome. The only drawback to using this at the moment, it's not stable yet, and also I haven't found how to do the kind of granular events that you can emit using something like Remit or your own implementation of that. If it got that, I'd be very excited and probably just delete all my own code. But this is a very good thing to do. And there's been interesting work in React PHP as well lately to have better child process management, to have child process pooling. We're all moving towards this idea that we can write asynchronous code very simply with the tools we currently have. And it begs the question, why write asynchronous code? Every time someone asks in Reddit on PHP, how do I do sockets in PHP? The default answer, in fact like 4 of them, there's always like 4 or more to 1 ratio, is use this other tool. Most often it's use Node and socket.io. It's never, well, this is a really simple way you can do it with a library that's stable and well tested. There's this concept going around, this idea going around that just because asynchronous PHP is implemented in other languages and other platforms and has been there for some time, that we cannot develop this idea for PHP. Well, people have already developed this idea for PHP. But why can't we use it? Now, part of being a professional developer means you need to know something about what you're making before you can charge about it. Otherwise, it's amateur development. That's fine. So if you only know Node, and you only know Socket.io, and you don't know this React PHP stuff or Async PHP stuff, use Node. I'm not arguing against using the best tool for you for the job. I'm arguing against the fallacious argument that you shouldn't do this stuff in PHP, that we shouldn't develop this stuff in PHP because it already exists elsewhere. PHP as a language is built up out of stealing ideas from other languages in time. It was never a language, it was a template engine that has grown into a general multi-purpose language that's being used for all sorts of crazy stuff. And we're appropriating stuff all the time from other languages because it just is cool like that. We can take the best ideas and the best patterns from elsewhere. Why can't we do this with async? Why can't we say, I have this use case that I could really use a message queue for, or I could really use a socket implementation on an event loop. Why can't we do that and try with PHP? There are so many reasons why it's a good idea to try and leverage the community, the knowledge, the libraries that we already have in the ecosystem, the code that we've already written in PHP, if we can make it work for our asynchronous use case. Why not? If for no other reason than this can open your mind to the ability to do asynchronous code, to the ability to create architectures that are non-blocking, reactive, event-based. If for no other reason, then you just want to stay with the townsfolk and deal with the relationship issues. Do this. Try async. That's why you should try it anyway, I think. Best reason anyway. Thank you. So 3 things. I forgot to mention at the beginning, Silver Stripe have also given me t-shirts like this to give away. And they're really awesome. I have quite a few different sizes in men's cuts and women's cuts. And they're here, so come and talk to me and ask for one. I have stickers to give away. It's awesome, and I'd love to talk to you more about this stuff. I'm particularly interested in talking about this stuff and generators. So if we run out of time, please come to the talk tomorrow. The feedback for this talk is on join in, and I would love it if you could tell me what I did wrong. I'm not really interested in hearing it was awesome and that's great, unless you absolutely want to say that. What I'm interested in hearing is how to make this talk better. So write that there, because that helps me make this better for the next people that hear it. And the third thing, I have absolutely forgotten. T-shirts, talk. I don't know.
Your async worker task isn't running.
Hey?
Your async worker task isn't running.
Yeah. That's dropped off. The events aren't emitting there. Okay, that's it. Thank you.
Are you putting your slides on joined in?
Yes, I'm putting the slides on joined in. I have also been taking a live stream of this to the internet, so there will be a video of this on the internet as well. I'll put links in there.
I want what you have.
Sorry?
I want what you have. And I was planning on coming to your talk tomorrow, so.
Awesome. Okay. Let me turn this one off. Okay, awesome. I have a bunch of different sizes. I'm just going to put them all out and then
Okay.
have a look.
Just for a large.
They
Fine one.
there are the red paper
That's
ones
small.
are male and the yellow wafer ones are female.
There's a large. You said the yellow ones are
The
female?
yellow ones are female, so it says
Okay.
yellow wafer on it. It's wafer written in yellow. Yeah, that's it.
Oh,
Right.
well, I picked up the right thing. And where are the stickers?
The stickers are here.
Woohoo! Let me get out of everybody's way.
Give me 2x.
Yeah.
I will.
Sorry?
2 extra.
Paper. Yeah. I have like one size of everything, so probably going to run out, but I may have more upstairs as well. No. It's 2XL here, otherwise I can go look upstairs.
You have medium.
Okay.
You have mediums.
Medium
Can you give me vast?
red paper, there you go. This is a
my
female.
girlfriend.
Yeah, there we go. I have more. I'll have them at the talk tomorrow. All the incentive, folks.
Are you coming to the big meeting at 4? You should.
Yes, I should. I have to leave at 4:45 for a elephant race. Okay. Or it's 3:45 or 3:30
Next session slot is 45.
Oh, okay.
So we're just taking down session slots to do 3A.
Okay. 3A.
It's over in Paradise.
Good talk, by the way.
Thank you.
So, from what I got out of it, it was most of that async PHP native stuff is very dependent on PHP 5.5 and above with the version.
React works 5.4. I'm not sure how long that's still supported because 5.4 is.
Well, I thought React. When they did a newer version, didn't they change the way the core was using all that? Or
I have no
I
idea.
don't know.
The 5.5 requirement is if the framework or the libraries use generators. So many of the popular ones do. React doesn't. And the last I checked, a lot of it still worked in 5.4.
Okay.
So you may want to check that out.
Cool. Thank you.
Hey.
The talk was fun.
Thank you.
I was just wondering, and it's more conceptual, I guess. So, how are the difference from running an async code, or would it be better if I can put stuff in a pipe and run them afterwards? Or are there like two different use cases?
So, like doing it mid-request or doing it after?
Yeah.
I don't think it makes much of a difference. You can do it after. I don't know. I think maybe a more practical, like context or code or something would be helpful to try and work that kind of thing out. But generally, like putting something in a queue is already going to, and taking it out of the request response cycle is already going to improve its performance drastically.
And I can see use cases where a client is not waiting for stuff, so I can just put them in a queue and run them, and when it's done, I can get back to them. But so if I do it async or do it concurrently, is there a limitation of how many processes I can run, or just depends on the system itself?
Depends on the system. With the doorman stuff I showed, there's actually, I forgot to mention this, but there's actually pretty cool processor and memory control. You can create rules to say, run 5 processes if nothing else is running, or if 50% of CPU usage is taking up, run 2. Yeah, it's pretty cool. I didn't show it here, I forgot to show it, but you can do that kind of stuff, which is pretty awesome. And the worker pool stuff that Kaysen, who contributes to React PHP and is called WiryHaximus on Twitter, the stuff he's been doing also has resource control in it as well.
I just wanted to say it was a great talk.
Thank you.
But what I would put a warning on top of this forking management, because there's, with forking there's always a cost, even if you have processes that are running. It just generates a lot of overheads, and most of the time when people think, I can work this in parallel, it will be faster, the cost of the forks is higher than doing that sequentially anyway, so you're just losing a lot of time where you don't need to fork. So from my experience, even if you're doing small IOs, forking is might be a problem, even in languages that have good threading models like Java.
Yeah.
Like in Java 8, they introduced a parallel collections, where you basically, in functional style, say, okay, map every item in this collection using this function.
Yes.
And it generated a lot of bus, and in the end, it turned out in almost all use cases it doesn't make any sense. It makes it slower. It's just really free. You just say any collection dot parallelize, and then you get returns a new collection. Then every operation is done in parallel, and just doing that just makes everything slower.
And takes up a lot of memory as you like more than the initial approach. That's good. That's good. I will add that up, but keep stepping up.
Thanks, been really cool.
Thank you for being there.
Thanks for the talk. I missed the first part of it. What are the main differences between React and Icicle?
Icicle is generator based.
Oh, okay. Generator based with yields.
Yes.
Whereas React is just promises based, or is it callbacks based?
React is, all promise stuff is callbacks wrapped in a nice API, right?
Okay.
But React's lowest level construct for managing the structure is a promise, whereas Icicle has promises, but as the smallest indivisible unit of work, it puts in a coroutine.
Okay.
Like generator.
Right.
And that's what it does for the smallest parts, and then the bigger sort of networked operations it'll do within a promise. I'm not sure at what point that switches over from coroutine to promise. They're interchangeable though. They obey the same basic interface.
Okay. I first kind of grasped really promises and how I was using them in Jeremy's talk yesterday. I was going to ask, when you say that Icicles is generator based or coroutine based, when you yield, are you always yielding a promise, or no?
Not always, but it's handled in Icicle.
In Icicle, the mindset of Icicle is when you yield, you should yield a promise. Is that
If
am I
you
right
don't
on
yield
that?
a promise, then what you
yielded will get wrapped into a promise.
Okay.
Yes.
Okay.
So.
Okay. But that's the